Okay, good afternoon everybody. Today we will continue with the stuff we did last week, 6.1. So first we will just refresh our memory on that stuff and then we'll build on that. So chapter 6 all kind of depends on this foundational stuff from 6.1. Hopefully now that you did homework on that, you remember it well and understand it well. And if not, then it will become more clear as we go along. That's the hope anyway. Another hope is that we will have a little bit more people in this class, because it's getting like the later in the day you go, the fewer people we actually have. That's quite amazing, because in the section before that I had like 16, 17 students, and we have 3 people now. That is seriously bad. I'm really hoping there'll be at least a few more people. Okay. Anyway, we do have to keep on going, and hopefully more people will come as we go along. Okay, so let's just look back a little bit. Remember what we did last time? We had these simple statements and compound statements. Simple statements have truth value, right? Something like this: Al-Qaeda is a humanitarian organization. Now let's look at this in isolation. Al-Qaeda is a humanitarian organization. A. Would you say it is true, or would you say it is false? That obviously is false. So the true value of that would be false, wouldn't it? Note, however, that when you add "it is not the case that," you obviously are changing the true value, right? So now we are saying not A. And what is the true value of this whole thing? It is not the case that Al-Qaeda is a humanitarian organization. So just think of it in terms of somebody told you that. Would you agree with that? It's not the case that Al-Qaeda is a humanitarian organization. True. Yes, exactly. So what is happening here? The statement itself is false, but when you negate it, it becomes true. So this is basically the idea behind true functions. All of them have these kinds of patterns, and this is basically what we'll be talking about today. So in each single case, there are rules which determine the true value of the whole thing based on true values of components. This is all there is to today's class. It may seem a little bit difficult, but the idea is just this simple. So again, remember what we use notation. When we have D and C, we put in a dot here, right? Either P or E, a wedge. If and then F, we put in a horseshoe or an arrow. I do have an error a lot there in the PowerPoints, but the book uses a horseshoe. Same thing, doesn't make any difference. P, if and only if R, we're using triple bar. Okay. Now, this is the operators, this is the names, this is the table from the last time. You should know all that. If you do not know that yet, you're in trouble, because you really need to know that for today. However, in itself, it's not really that difficult. Okay. Now we will deal with true functions for all this compound proposition. What is a true value? The true value can be completely determined based on this. Let me see, where's the definition? True function of any compound proposition whose true value is completely determined by the true values of its components. So any proposition which we can figure out the true value of is a true function. And if we know the true value of the components of all these propositions, we can also always determine their true value. Now, statement variables. What are the statement variables? Well, the propositions themselves, we're naming them like A, B, C, based on first letter of the word there, of the whatever words you use, yeah, right? So this is particular statements. But you can just, instead of saying A, B, or C, use the letters P, Q, R, S. And they would just equally stand for any proposition there is. That's just like this basic stuff. So this is in logic, we typically use these lowercase letters, P, Q, R, and S. They just stand for all that. Also, they can stand for a more complex proposition. So for example, you can say that A is P. Or you can say that if A, then B. That whole thing is P. Or you can even say something like if A, then B, or C. And you can say that whole thing as just, let's call it P. You can do that. It's like matryoshka, you know, the Russian dolls matryoshka. You put a whole bunch of them inside, and there's one doll covering them all. So that's the idea. Again, don't worry too much about that, but this is just the idea behind these lowercase letters. They can stand for almost anything, and we will be using them just because it's easier than using the concrete examples. Okay, what is a truth table? Truth table is simply all the possible cases, every possible case which a proposition can take. Let's go back here again and take a look at this example, right? Now, instead of A and not A, we can use P and not P. So, suppose we have P and not P. Let's say we want to figure out all the possible combinations that can take. So if P is true, what would be not P? False. Excellent. And if P is false, what would be not P? True. Note that there's really nothing else. We're done here. For P, it is very easy. This is our truth table. It lists all the possible combinations. One important thing, for some reason, when we get to 6.6, students completely forget that and they get confused about one simple thing. Not P by itself is neither true nor false. Not P is just not P. Okay? For whatever reason, students don't seem to understand that. Note that not P can be either true or false based on whether P is true or false. I will repeat it again when we get to that, but this is one thing which students have trouble with. So this is the table again, just the same one as I did on the previous example. So one more elaboration in terms of the language, how you know these cases. Like, suppose you are told McDonald's makes hamburgers. That's your statement. Is that true? Yes, so it is true. Let's call it M. So if M is true, but you are told it is not the case that McDonald's makes hamburgers, the whole thing would be what? True or false? False. So not M is false. On the other hand, Starbucks makes hamburgers. Is that true? That one is false. And in that case, it is not the case that Starbucks makes hamburgers. Would be true. Exactly. So you see, not M is false, but not S is true. Again, just think about it as flipping it on the other side. You don't know whether it's true or false, but if you have any true value, you have to change it to another one. And sometimes when students are not given the true value, they somehow start thinking about not M or whatever as necessarily being false. No, it doesn't mean it's false. It just means it's opposite of whatever it is. Okay. Now, next one will be conjunction. Remember our conjunction P and Q. What is the rule here? For our purposes, we simplify it greatly because this is the table with all the possible truth values. But you guys only have to remember one of them because there's only one situation here which will help you determine the true value of the whole thing, and this is that one. When both of them are true, the conjunction is true. In all other cases, conjunction is false. So both true, true. Just remember that. For conjunction, if both true, true. In all other cases, false. Now let's look at the language and see how it works in language. Suppose you are told Ferrari and Maserati make sports cars. Is that true? The whole thing. Yes, because Ferrari makes sports cars is true and Maserati makes sports cars is true. For those of you who don't know much about cars, GMC doesn't make sports cars. So how about this statement? Ferrari and GMC make sports cars. Is that true? No. Note that GMC not making sports cars spoils the whole thing. So even though this one is true, the other one is false, the whole thing becomes false. So this one was true, this one's false. Now how about GMC and Jeep make sports cars? True or false? False. Because neither of them make sports cars. So again, this one is false, this one is false. Both of them together are false. So that just again explains to you why there's only one case when both of them are true. The whole thing is true if both of them are true. Any one of them, be it this one or this one, spoils it. And if both of them are false, then it definitely spoils it a lot. So in all these cases, it will be false. The only time when it is true, when both of them are true. Now, how about disjunction? Our good old friend disjunction, when you're told either this or this. Now, with disjunction, you also have to remember one thing, and one thing only, and it is when both of them are false, the whole thing is false. In all other cases, it is true. So it's always true, except when both of them are false. Now let's look at language again to see how it works. Before we go through this, I want to make sure we're all on the same page, because periodically international students complain to me and say, who are all these people? I never heard of them. I don't understand this example. So let's just clear it up first. Stephen King, is it true that Stephen King is a novelist? Yes, he is a novelist. How about Kate Blanchett? Is she a novelist? No, she's an actress. How about Danielle Steele? Is she a novelist? Yes, she's a novelist. How about Kobe Bryant? Is he a novelist? No. And how about Tiger Woods? Is he a novelist? No. Great. Now that we're all on the same page, we can go through the examples. Just wanted to clear it up. Okay, so if you're told either Stephen King or Kate Blanchett is a novelist, is that a true statement? Why would it be false? You are told either Stephen King or Kate Blanchett is a novelist. Isn't it true that either Stephen King or Kate Blanchett is a novelist? Of course it's true, because the way it is phrased, it doesn't tell you both of them are novelists, it says one of them. Either this one or that one. And it is true. So it is true. Now how about either Stephen King or Danielle Steele is a novelist? Is that true? Yes, definitely. It's like both of them are novelists, so it is even more true, if you can say that. But in our case, it's neither more or less. It's either true or not true. And in this case, it is true. Now, how about the last one? Either Kobe Bryant or Tiger Woods is a novelist. Is that true? Now that one is definitely false. So you see why it's only false in that last case, because when both of them are false, it is false. And we, in language, follow the same rule exactly. Because you're given two choices, as long as at least one of them is true, the whole thing is true. You are told either Stephen King or Kate Blanchett is a novelist. Yes, it is true. Stephen King is a novelist. Either Stephen King or Daniel Steele is a novelist. Yes, it is true. Both of them are novelists, so obviously either one of them is a novelist too. But if you're given two false choices, either Kobe Bryant or Tiger Woods is a novelist, now then it is false, because neither of them is a novelist. Okay, lovely. In some cases in language, you can have what is known as exclusive disjunction. Something like that. Orient Express is either on track A or track B. What is the difference with the previous example? Well, the difference is, unlike with Stephen King and Daniel Steele, the Orient Express cannot be simultaneously on track A and track B, right? So it cannot be both true. It's impossible. So what do we do in this case? Well, actually, in logic, then you have to notate it differently. You can no longer say something like A or B. That's not good enough, because you have to show that this possibility is excluded. How do you do that? Well, actually, you can do longer statement like this. So you're saying A or B and not A and B. So you are excluding possibility of both of them being true by saying that should not be the case. Don't worry too much about it again, but just keep that in mind, because sometimes language has this kind of situations. And in logic, of course, you cannot just immediately translate it. Okay, now let's do first extra credit exercise. Super easy if you paid attention. All I need you to do is tell me the true values of these two compound statements. B and not Y, and X or not Y. Note that you are told already that A, B, and C are true, X, Y, Z are false. So you just need to calculate true values of these two based on these rules, and you can just tell me in chat. That would be two words, whether like true, true, false, false, true, false, whatever. The first person get it right gets extra credit. Think about it for a minute or so. Make sure you get it right. Sandy, you cannot. What do you mean? There's only two of them. So I need to have the total result for each one of them. So you see what everybody else is doing. 2 would be either true or false, and 3 will be either true or false. Okay, now Emil did get it right. Emil, good job. That's your first extra credit. Great. Remember, guys, this is important extra credit for the final exam. It will apply to the final. We only have one person now, Martine, who is already at the maximum. So I'm sure Martine follows that, but she doesn't have to submit answers anymore because she's not going to get extra credit. But for everybody else, you definitely want to take your opportunities and get the extra credit. Okay, let's look at it together, how it's done. It's done very simply. Sandy, since you've been confused, pay attention. So you are told that X, Y, Z is false and A, B, C are true. So you have true, right? B is true. And you have not Y, which is not false, since Y is false. Okay. Now, based on that, you have true and true. So what's the total result of true and true? It is true. So 2 is true. Okay? Now, how about number 3? You have false. X is false. And again, you have or not false, just like in this case, because it's not Y. So we already know this is true. But what's the rule for disjunction? It's only false when both of them are false. See, but this is when these rules come important. And if you know that, you immediately know that the whole thing is true. So whereas the conjunction is only true when both of them are true, disjunction is only false when both of them are false. So since this is not the case, it is true. Okay, so now you can see both of them are true. This is how it's done. We will do more in the end, so hopefully that clears it up. Okay, so the correct answer is both of them are true. Okay, let's continue. We still have a few of them to go. Now, conditional statements. Remember the conditional statements. We did work with them before. The whole thing now we call it material implication. The relation is material implication. And it also has a simple one rule. When your P is true and your Q is false, the whole thing is false. So this is your antecedent, this is your consequent. Remember, when your antecedent is true and your consequent is false, the whole thing is false. In all other cases, it actually is true. So this is what the one you should really remember. It only is false when you go from true to false. Okay, now in language, it may get a little bit confusing for some students. But if you think about it, you will understand. So let's go over them, but first let's make sure we are on the same page. So is Nicole Kidman an actor? Well, she's an actress, but an actor, the book says an actor. Yes, so okay. How about Meryl Streep? Is she an actor? Yes, great. How about Wolf Blitzer? Do you guys even know who Wolf Blitzer is? I was a little bit surprised that so many students don't know Wolf Blitzer. I guess you don't watch CNN much. Not an actor. CNN presenter. One of those on-the-air guys who talks about elections and stuff. So that would be false, right? That would be true. How about Jennifer Aniston? I'm sure you guys know Jennifer Aniston. Apparently Friends is so popular now, I'm quite amazed. You know what, I watched it back in the 90s when it first aired. And I loved it. I started watching it in 96, but I never knew that in 2020 young people will still enjoy it so much. But anyway, one of those shows which still kind of the spirit lives on. So anyway, yeah, one of my favorite shows of all time. Jennifer Aniston is of course an actress, so true. But Wolf Blitzer is not an actress, so false. Now, last one, Anderson Cooper. Do you know Anderson Cooper? Again, he is not an actor because just like Wolf Blitzer, he is a CNN presenter. So if you watch CNN, you should know. Great. So we are all on the same page now. Let's look at that. So if Nicole Kidman is an actor, then so is Meryl Streep. Is that true, the whole thing? Yes, it is true. That's of course easy to figure out. If Nicole Kidman is an actor, then so is Wolf Blitzer. Is that true? No, that is false. You can see immediately something rings wrong here because she's an actor but he is not. Now the other two can be a little tricky. So let's think about them. If Wolf Blitzer is an actor, then so is Jennifer Aniston. Is that true? Yes, it is true. Now how about if Wolf Blitzer is an actor, then so is Anderson Cooper? Is that true? Yes. Again, the answer is yes. Note why these two are true. The important thing here is your antecedent. Antecedent, if Wolf Blitzer is an actor, automatically puts a condition. If this condition is not satisfied, then we really do not care very much whether consequent follows or not. The whole thing will be true. So that's why they are true. Kind of think of it in this way. Suppose I tell you, if you get an A on the final exam, then you will get an A in the course. Right? Suppose I tell you this. As long as you get an A, regardless of your points, as long as you get an A on the final exam, you will get an A in the final course. Note that that does not exclude the possibility that you will get an A in the course even if you don't get an A in the final exam. So under what condition you would say I lied to you? If you got a B on the final, but you got an A in class, would you say I lied to you when I said if you get an A on the final exam, you get an A in course? No, if you think about it, no. The answer is no, because even though you did not get an A on the final exam, I never said that's the only situation when you will get an A in course. If I told you, if and only if you get an A on the final, you will get an A in class, then of course you, if you got B, you would not be able to get an A. However, if all I tell you is if you get an A on the final, then you get an A in the course, then you can only look at it in terms of, did I satisfy the first condition? If you satisfied the first condition and the consequent did not follow, you got an A on the final and still you got B in class, you would immediately say, hey, what the hell is going on? That is a deception. I got an A on the final, how come I don't have an A in class? But if you got B on the final and I still gave you A in class because you have enough points or something, right? Why would you complain? What crazy person would complain about that? Yes, the condition is not satisfied, but I didn't lie to you, right? So that's why this situation here with Wolf Blitzer and Anderson Cooper, or with Wolf Blitzer and Jennifer Aniston, is actually true. Because if this is false and this is false, the whole thing actually is true. There is no lie here, since the first part simply not satisfied, and therefore condition itself did not even apply. And if the condition did not apply, then that whole thing is true. It may be a little bit tricky for some students at least. So that's why I explain it in more detail. Okay, and finally, biconditional statement. Biconditional, remember, is if and only if. Now here we have this type of relation when we have both implication going both ways. If P then Q and if Q then P. For this reason, it can be true twice. It can be true when both of them are true, and it can also be true when both of them are false. In both of these situations, you will get yourself true result, and it will only be false when one of them is true, the other one is false, no matter which one. Okay, so that's the only one when you have true twice, if both true or if both false. This is some examples, and again, let's first figure out who are we talking about here. Bill Maher, is he a show host? Yes, okay, so that's true. How about Jimmy Fallon? Yes, lovely. How about Emma Watson? Is she a show host? No. How about Matt Damon? Also not a show host. So false, 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 and that one is true. Okay, so let's look at them now. Bill Maher is a show host if and only if Jimmy Fallon is. Is that a true statement? Just think about the wording of it. Yes, it is true. How about Bill Maher is a show host if and only if Emma Watson is? No, because clearly something is going wrong here, so that one's false. But how about Emma Watson is a show host if and only if Matt Damon is? Is that true? Yes, actually it is true. You see, when both of them are false, if you say, well, Emma Watson, she's a show host if and only if Matt Damon is a show host. That actually sounds completely true, because neither of them is a show host. So to say one of them is a show host if and only if the other one is of course true. So again, it makes sense in terms of the language. Okay, let's do another exercise. This one will be a little more difficult because you're going to need to remember the rules from last session. And if you do remember the rules from the last session, you should be able to determine the true values here. But I will also want you to write me notation. So let's say that Julius Caesar is J. Let's say that Napoleon ruled France is N. So Julius Caesar conquered America is J. Napoleon ruled France is N. Lincoln wrote Gettysburg Address is L. And France bombed Pearl Harbor is F. Now note that I give you the true values here. Why do I do that? Well, because it's not a history class. It's actually, in the book they don't do that, but I discovered that not everybody knows who the hell wrote Gettysburg Address and so on. And since it's not a history class, I cannot demand that you guys know that, so I already tell you. Julius Caesar conquered America, that is false. Napoleon ruled France, that is true. Lincoln wrote Gettysburg Address is true, but France bombed Pearl Harbor is false. Okay, so now you have J, you have N, you have L, you have F, you have their true values. You have to, and I will turn on the board, you have to write down for me the form for both of them, for 6 and for 8. And so the form and then the truth value. Calculate the truth value for each one. So it's a little more complex, closer to what we did last time. You have to apply the rules from last time, but again, if you get it correctly, you'll get extra credit. If you want to do it, again, tell me in the chat and I will turn on the multi-user board so you can actually write it down here. Make sure first you are sure about your answer. Okay, well, first of all, one note that this is N, of course, and not F. So you have to be consistent in that sense. If you want to use true for falsity instead of the letters, you should have done it for both or the other way around. But in any case, regardless of that, this is incorrect. There is a problem here. So if somebody wants to fix that, I'm going to remove this. If somebody wants to fix that, then you can try it. Well, if somebody tries and gets it wrong, then Sandy, you can do it again. But otherwise, if they get it right, I wouldn't give it up to them. Why do you want to help out somebody else? It's nice, but then they will get extra credit. So keep it to yourself for now. Let's see if somebody can spot what the problem is. Well, anybody else? Anybody else following that? Otherwise, I'll just give it to Sandy and we move on, because I mean, I don't want to spend 20 minutes on one problem. There's still more exercises in the end. I'll give you about 10 seconds. If nobody wants to do it, I'm giving it to Sandy. Okay, Sandy, you got it. By default, since you're the only one who answered. Okay, so let's see what the problem is. Well, I guess you already figured it out, right? Because it's if, you have to switch them around, right? And then you will get N, J, not the other way around. And then your value would actually be false. And in this case, you have L triple bar F, and your value will also be false. So this is the correct answer. You can see why, right? Because it's just if, and remember, if it's only if, you have to put second one here and first one here, and based on that now it becomes from true to false, which actually is false. Okay? So that is something from the last time, but I mean, you guys did homework and everything. I'm assuming you should know it by now. Otherwise, you are in trouble. Okay, and so you see, it also makes sense to do it first, because sometimes if you only one who do that, then you may get extra credit even if you got it wrong. Okay, let's look at some other stuff we need to know here. Suppose you have a longer proposition. How do you calculate a true value for a longer proposition? I kind of will do it in one go for all of them and just do it on the board for you guys. So then you just follow the very simple rules. First of all, you have to remember what we just talked about, the rules for all of them. And second of all, you have to methodically apply them. So let's say you have something like this. Let's say you have something like A or D. Therefore, let's say Well, it's slightly different than the example in the book, but I'll do it right away like that, just so that it would be easier for you to understand. Suppose you're given that. Now then you also are given A, B, C are true, and D, E, F are false. Can you calculate the value of this? Sure. And this is how you do it. First, just methodically write down the true values for all of them here. So A is true, D is false, and not E is again false. So just, all of them, give them the true value. So now you have just a bunch of true values, right? Now apply the rules. And just like in math, you do what's in parentheses first. But every time you have a negation, you actually have to do that first. And this is not in this example, but this is in the next example. So when you look at them, this is the easiest thing to do, right? Negation, in this case, if it's not false, then it would be true, right? So true or false, then true. So now we just removed the negation, flipped it back to true. Now you can do it in parentheses. If you had, like, for example, not false in parentheses, you would also change it for true. If you had negation in front of the parentheses, you do not do it until you calculate the parentheses. So negation, individual letters, always comes first. But negation of whole thing in parentheses, once you figure out the parentheses, then you do. So you've done this part, now you can do the parentheses. What would be the value in parentheses when both of them are false? There is false, because it's disjunction, but both of them are not false, so it is true. So you have this. Now this is implication, so from true to true, it is what? True. So the whole thing is true. Note that in the example in the book, next one is actually false. Why? Because I added this part, they didn't have this part. If you don't have this part, let's do it without this part. This is how it is in the book. So now that would be true or false, but that would be just false. So now you calculate what's in parentheses, true or false. The rule is when both of them are false, it is false, so it is true, and this one is false. So note that now the whole thing is false, because if it's from true to false, that is false. So this is how it is in the book. Just so that I wouldn't have to do it twice, I kind of simultaneously did the one with negation. Okay, so going back to the slides. First you enter true values, then compute for compound, if you have some compound in parentheses, and then just follow the same pattern. So you see, this is the same example in the book, A or D, therefore E. So they also enter F, true, false, false. Then they calculate the parentheses, which gives you true. This one's still false, and then the whole thing is false. It's a little bit longer way than what I have on the board there, but it's the same idea exactly. It's just they kind of add few more steps to chew it a little bit further. And once again, suppose this is the example with negations. So if you have negations, how do you do that? You are given not C or not A, therefore not B. First thing you do in this case is, again, you just enter the true values. So all three of them are true, right? A, B, C. Second thing you do, you negate the ones which have negation right next to them. So since it's not true, it becomes false. Since it's not true, it becomes false. So now you calculate what's in parentheses. True or false, that gives you true. But you keep this negation outside of parentheses, just like in math, because it's outside of parentheses. And then you finally use this negation outside of parentheses for this true value inside, which gives you false. And this one you just copy it. And now you have from false to false, that is true. You see? Do you understand? You can do it for any length of them. And again, this is just how you do it. If you have tilde, negation, immediately preceding letters, just do it first. Operators joining letters or negated letters, tildes immediately preceding parentheses, and so on. This will be on a homework. Somebody asked me in another class, is this going to be on the exam? Well, as usual, what you have on the exam will be the simplified version. It's not going to be as difficult, but it will be basically the same idea. So it's not really as long as this, but you have to know how it's done. Okay, let's do the exercises now. So the first exercise is just like the previous one we've done. For one thing, it is not the case that either Julius Caesar conquered America or Washington was assassinated. And again, I need you to write it down for me. So Julius Caesar conquered America is J, Washington assassinated is W. Give me notational form and give me the complete value. So Julius Caesar conquered America is false. Washington was assassinated is also false. Based on that, whoever is ready to do that, let me know in the chat and I will turn it on for you. And if you do it correctly, you get extra credit. I'll be right back. Okay, that is much better, because note that yes, it is not the case. What happened to it is not the case. You still have to use the it is not the case. And remember, just like we did last time, since it says either this or this, you put these two in parentheses and you negate the whole thing. So it is not the case that either this or this. And now, if you apply the rules, of course, this is false, so the whole thing is false, but you have a negation of false, so the whole thing becomes true. This is your final answer. It is absolutely correct. So, Eric, good job. That is your first extra credit. Okay. Lovely. More people get an extra credit now. Okay, well, we will do, of course, more of them. So this is correct. This is kind of nicely laid out. Looks like this. How about this one? Same exact task. You have Lindbergh crossing the Atlantic, which is actually true. You have Edison inventing the telegraph, which is false. You have Nixon resigning presidency, which is true. And you have Edison invented telephone, which is false. But the goal is to write down the whole thing in properly notational symbolic form and then figure out the true value. A little longer than the previous one, but I'm sure you can do it. If you're ready, let me know. Remember, if nobody does it correctly, then the person who tries it will get the extra credit. Closest one, the person who gets the closest, if there's more than one. Or if it's only one, like Sandy, then Sandy got extra credit. Alright, what do you guys think? So, either Lindbergh crossed the Atlantic and Edison invented the telegraph, or both, Nixon resigned the presidency and it is false that Edison invented the telephone. And then once we do that, of course, we are already told that this is true and this is false. So they only are true when both of them true, therefore it is false. And in this case we have n, we are already told is true, and it is not f. And not f, of course, again is true. So true and true, therefore true. And finally we get this disjunction of either f or true. And remember that in disjunction it's only false when both of them are false. So the result is true. Great job, Eric. Once again, yeah, second extra credit for you. Yeah, some students suddenly are very good at it. Well, great. I'm very glad that it works so well. Okay, hopefully the rest of you guys can catch up too. Let's do one more. This one is actually supposed to be easier because this is exactly the one we did last time, identifying the main operator in all of this. So in all four of them, you just have to circle it for me. So for example, if it is this one, then you will circle that. Of course, it's not this one, but in each single case, you just have to circle it. Whoever wants to go first, let me know. Sandy, okay, but be careful, so go ahead. Aha, good job. You almost made a mistake here, and sometimes students do go for this one, but you have caught up yourself in time, because yes, note that indeed there are brackets over this whole thing, so it actually is a negation. Great job. Okay, so that's your fourth extra credit. Almost at the maximum now. Oh, and there's Vasily saying hello. Vasily! No, well, that's his way of saying hello. but yeah, he decided to give you a cheer as well, in his own way. Okay, anyway, now let's do one more like this. This is just like the one we did before, and I'm just looking for true value for both of them. So again, it's like false, false, or whatever it is. The first person to get it right gets extra credit. Should be easier now, right? Well, you should be better at this, guys. At this point, I mean, that's a fairly easy one, just like the one we did at the beginning of class. You're given ABC true, XYZ false, just calculate two true values. Should be easy breezy. I'm not gonna turn it on or whatever, just let me know. Oh, great job, Sandy. Yeah, exactly. See, that you caught up with it. So B is that's why B is true, and not Z. Z is false, but not Z would be true, right? So the whole thing would be true. And here we just have this identity. B is true and Y is false. It's only true when both of them are either true or false, so the whole thing is false. So true and false. Great. See, you got your last extra credit now. You have 5. Made it there in one class. Great job. Okay, well, you still, of course, should try the exercises, but now you no longer have to submit them. You can just do it for yourself. Okay, let's do one more. In this case, it's just a little bit longer. There's 3 of them, not 2, and they are slightly longer. So it will take you a few minutes to calculate them. Make sure you do it, and just again give me the 3 answers, which would be something like either true, 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 or whatever, true, false, true, false, true, true, whatever combination it is. That's all I'm looking for. If you get it right, you get extra credit. Should take a few minutes. Yeah, it might take a while. Now let me do the first one for you guys myself. Maybe that will be helpful to some of you. So that one. Okay, let's do it right here. So you have not B, or if Y, then A. How do you do that? first just enter the values, right? So you have not b is true, so not true, or y is false, so false, and therefore that one is true. Okay, now the next step is, since you have one negation, change that, so that would be false, right? Or again, just copy everything else. Next step, you do what's in parentheses. What's the rule for this? The rule is it's only false when you go from true to false, so in this case it is true. So you copy that part, and then you just have this. And again, remember, for this junction, it will only be false when both of them are false, both of them are not false, so it is true. Okay, so hopefully that helped in case if you're not sure. So this one will be true. Now just the other two are left. Good. Well, you can't have any more extra credit, but certainly it's good that you are getting it so well. That's just methodical application of these rules, which is why I said before that it's, in that sense, it's kind of like math. As you can see, it's not math, but it's like math. And by the way, this is sometimes students ask, well, that is logic, but that logic actually did make its way to math, because in math they're writing proofs this way. And sometimes students ask, what else is it good for? Well, actually, the amazing thing is, this is good for computers. And for many centuries, people were not sure how to use that stuff, but today we discovered that actually all the computers programs are using this kind of logic, and this is what computer programming essentially is. So how do computers work? Just a little bit of going into that area for those of you guys who don't know. Computers work very simply because all they have is electric current going in, right? Electricity. And electricity works on the basis like we have true and false, right? Electricity just works on the same basis, except it is 1 and 0. So when there is a signal current, it is 1, and when there isn't, it is 0. So then you can send string of them into the computer through the wire, and it looks like this: 0, 1, 0, 1, 1, 0, 0, 1, 0, 1, 0, 0, and so on. Now, each combination stands for particular letter, like A, B, or C, particular number, and so on. Everything you have on your keyboard is a combination of ones and zeros. Computer simply uses this type of rules to determine what do you want it to do. When computer gets a particular string like this, it displays particular letter, for example, on a screen. A certain combination can tell computer that the screen is supposed to be green color. A certain combination can tell computer that it's supposed to pull a picture from whatever file, and so on. So computer just methodically follows these rules just like you do. And as a result, we get internet and we get all these computers. And your smartphones are doing the exact same thing too, except they're very tiny computers, but they also follow all this stuff. So the reason why we have all this stuff is because of this. Amazing as it may seem. This is the answer, how computers work. Yeah, it is very cool. And like I said, for a couple of thousand years, people knew that this is very cool because it goes all the way back. Well, actually, this type of stuff, the propositional logic, goes back to Stoics. Stoic philosophy. Stoics were working on logic after Aristotle, and they were working in conditional statement and so on. But people were like not sure. What the hell do they do with all that? It seems pretty cool, but what practical application does it have? And it wasn't until 20th century when people finally started applying it to computers and getting the results, the amazing results which we have today. And like, whoa, that really does work. So if you ever want to be a computer programmer, you will start learning all these computer languages like BASIC and whatever other they have over there. They just basically tell you how to write this sort of thing so that computer could decipher it. It has different ways to enter it, but the essence is the same. It's a binary system, true and false system, which follows the rules based on notation. That's all there is to it. Okay, does anybody want to correct the last two, or should I just give you the answer? I'm sure somebody can do it. Come on. There's just two of them left. Still have a little bit of time, so go ahead. No, whoever got it, but I mean, Sandy, you're not gonna get extra credit, so I'm just saying you guys go ahead, not you, Sandy, go ahead. But you go ahead on your own piece of paper, and then you will see the answer and you will double check that you got it right. That's about as much as you can do at this point. And this is the last exercise, by the way, but I still want somebody to get the extra credit. Come on, guys, there's almost nothing left. There's one more class this week, and there's one more class next week, and that's it. After that, just review. Next week we only have one class, because Thursday is Thanksgiving. So we only meet Tuesday next week, and after that review, and after that final. Very little time left. You will need this extra credit on the final, trust me. Yes, you might. If you're the only one who tries, or if you're closest to the correct answer, you'll get the extra credit. Well, there's no penalty for trying, right? So just do your best. Well, see, Eric, that is actually correct. That is correct. So what were you afraid of? That's your third extra credit. See, even if you're not sure, what do you have to lose? I don't deduct any points, right? Yeah, so this one is false and this one is true. That is exactly the correct answer. Well, if you guys want, we can do 12 together, just since we have a few more minutes. So again, look, this is how it's done. So this is what we have, or not. Why? This is the original one. You just rewrite it using these values, right? ABC true, XYZ false. So true, and this one is false, and this one is false. And then you keep all this notation here, just like it is over there. Now, next step, since you have negation right next to the letter, you change that, right? And you again rewrite everything, just like you have it. Okay, next step, you calculate what's in parentheses. It's only false when both are false, so it is true. And you keep this negation, and you keep this true. Now that becomes false, of course, because it's not true. And you rewrite this. And the last bit which you have, remember, it's only false when it's from true to false. And it is from true to false. So it is false. That's how you do it. Okay? Just like I said, methodically follow the rules. It's really not that difficult. Okay, I guess this is all we have for today, unless you guys have any questions. Anybody unsure about anything? Okay, great. So in that case, I guess we can finish a couple of minutes early, and I will see you again on Thursday when we will continue with this stuff. Have a great day, and I'll see you Thursday.